Hey, what's going on, guys? Caucasian Mark, the whitest student on the internet. Today we're talking about good old abstract classes. Now, in my academic studies, I didn't see a whole lot of these. I used an interface or interfaces more often, but interfaces and abstract classes are very similar in many ways. It could get a little confusing, but we can think of an abstract class as when you want to extend functionality of a class that you made with other very closely related classes. So I think we could think of this as interfaces as you want a overreaching, if it walks like a duck, talk like a duck principle across your classes. So say you have an interface that really denotes and talks about movement functionality. So all your objects that would be of the type that would move, say you have a car or a person or a bicycle, something along those lines, you would want that movement implication scattered and shoved across the board, right? With an abstract class, the way I've used them personally is you want a much tighter relationship, more of a one-to-one, one-to-two type of situation rather than something completely across the board, because then I think it'd be easier to do an interface. So let's just show how they work in real time here. So we could create a class like we had before for Muppets, for a practice, for a puppets class. But one thing we want to change here is we don't want it to say public class actor. We want it to say abstract, because we can't make an actor class or we can't make an object out of it. We have to extend it through another class and subclass it. Now, if you're like, Mark, what does all this thing mean? Slow down. I can't handle this right now. We'll break it down for you. Inside of here, we could have abstract and non-abstract methods that we could use. We could also make it just like any other standard kind of class. We could have a constructor, we could have data types roaming around doing different kinds of cool stuff, but we can't make an instance of the actor class whatsoever. So say we come into puppets here. We say, hey, I'm extending actor, which is the only way you could use an abstract class. So this is a kind of the one-to-one relationship here that I'm trying to imply. So then what we necessarily have to do with the puppets class now is bring in and override the methods of wiggle and walk, which are abstract. There's no way around it. The compiler will force you to do it, otherwise the program won't work. So then we override the methods up here, because these are just general blank method signatures, and so that's how you write an abstract method. You come down here and you fill them out, and for this I just have it print out to the screen, wiggle and walk. So then we could go into our practice class here and say, let's make a new puppets object. So we have a pup right here, and say we want to do walk, and let's just make it do wiggle, and we're going to run this, and it walks and it wiggles. Awesome. But is anything impeded by the fact that this, I fucking hate that thing at the top, that this actor class here has this void method, it says die, and it prints out can we still use that even though we had to come in here, we had to make it abstract, we had to override these? Does that change anything at all? And the answer is no. Since we're extending it, see, the thing just died now. I don't know how a puppet dies, but I imagine the actor itself died, or something likely just as violent. But just because we have to override the abstract methods when we extend the actor class here does not mean that we lose the other benefits of the relationship to other methods that we could inherit. So that is abstract. That's kind of a simple, I guess, overview of it. If you have any questions, leave them below. I could probably do another video, another example. Like, share, subscribe, thumbs up, drink a beer, hug your mother, do something like that. I'll see you in the next awesome, sexy, erotic